So, little with function notation. We've talked about before, we have what's called function notation, where we use a small case, lowercase letter to stand for some rule. And we're going to do that rule, apply that rule to some values. And those go in the parentheses. And we refer to our values going in as inputs. They're our independent variable. And then we get outputs. So our rule here looks like we take an input x, and our output is we square x, we multiply it by 3, we add 7 times x, and then we subtract 1. And so our rule is a quadratic rule, if you will. So let's suppose we wanted to find here f of a. Instead of f of x, f of a clearly is just going to be 3 times a squared plus 7 times a minus 1, or 3a squared plus 7a minus 1. Suppose we wanted to find f of 2a. F of 2a is going to be 3, my input is 2a squared, plus 7 times 2a minus 1. Or, let's see, 2 squared is 4, 4 times 3 is 12a squared, plus 14a minus 1. How about we want to look at something a little more complicated, like f of x plus h. F of x plus h is going to be, in this case, let me get this back down to where we need it to be. F of x plus h is going to be 3 x plus h quantity squared plus 7 times x plus h minus 1. Simplifying, 3 x squared plus 2xh plus h squared minus 7x minus plus 7h minus 1, or 3x squared plus 6xh plus 3h squared minus 7x. That's a plus 7x plus 7x plus 7h minus 1. Any like terms? Nope, no like terms, and that's what we got. So, when we look at functions, there are primarily 4 ways that you're going to be given a function in this course, in calculus, and whatever you're doing. You may be given a table of values and asked, is one variable a function of the other? You may be given some rule. We just looked at the rule, the f of x equals 3x squared plus 7x minus 1 is an algebraic rule. You may be given a set of ordered pairs and say, hey, these ordered pairs, does it appear that they define a function? The 4th way is you may be given a graph. Said, hey, here's a graph. Does this graph represent y as a function of x? So for a function, our definition was, for each input, there will be one and only one output. We refer to those input values, all possible values, to be the domain of the function. Call them domain values. Our output values we refer to as the range values. So consider a function y equals 3x. And again, we've got 2 notations. We're going to kind of move back and forth between y notation and f function notation. Y notation you've seen before. Y is simply the output, and our input, our rule is the tripling rule. We take any input x, we triple it, and we get an output. And we would say that y is a function of x such that y is the tripling function. It takes an input of x and triples it. We can also refer to this function, the tripling function, as a function of t being 3t, and I would say f of t equals 3t. What's the domain for this function? What are the permissible values that I can triple? Well, clearly I can triple any number that I want, so therefore my domain is all real numbers. Now, what's my range? How small or how big could the numbers be that I get out from tripling something? Well, clearly, if you think about it, if I've got some output, its input would be 1/3 of that. So any number that I've got, could I take 1/3 of it and get the corresponding input that would give me that output? Certainly. And my range is clearly all real numbers. And if I think about it graphically, there's my line y equals 3x, let's say. Is the domain all real numbers, and is my range all real numbers? Clearly, yes. So here's a sample problem from the book, from the class exercises on page 122. Number 6, it gives you 2 equations and asks you, does either one define y as a function of x? So if we look at the first one and solve for y, we get y equals x squared minus 1. So the question is, if I put a value in for x, square it, and then subtract 1, do I get one and only one output for any number x that I put in? And the answer clearly is yes. So certainly the first expression does define y as a function of x. How about the second one? Well, the second one, when we solve for y, we get y squared equals x plus 1. And when I take the square root of of both sides of an equation, I must make sure that I include plus or minus. So y equals plus or minus the square root of x plus 1. The question is now, if I put an input in, do I get two different outputs at times? And the answer is yes. Consider, for example, if I were to put as an input here just 0. If I let 0 be an input, then my output will be I'm either going to get positive 1 or I'm going to get negative 1. That means this rule, y assigns either 1 or negative 1 to an input of 0. Hence, the second expression here does not define y as a function of x. It defines y as a relation of x.